Hi, everyone. My name is Weiwei Gong. I'm also from Oracle. Today, I want to talk about SQL in Silicon, how we process the SQL queries on specialized hardware. As we all know, Oracle is a vertically integrated company. We have the application, we have middleware, we have database, we have operating systems. A few years ago, after we bought Sun, we started to think whether we can integrate it with the SPARC processor. So we spent some time and energies to build a specialized coprocessor and put on the chip. We provide fantastic asynchrony. We can support thousands of outstanding reads, and we have a much better support for pipelining, streaming. So we can use that to help us doing the security check, the data decompression, and the SQL accelerations. By using the SPARC general purpose core plus this specialized coprocessor, we can run the complete Oracle stack. This slide shows the SPARC M7, which was released last year. I want to highlight one thing. On this chip, there are 32 SPARC cores and 32 database accelerator units. However, those DAX units, 32 DAX units, takes only 1% of the area, but it can have a combined effectiveness of up to 96 SPARC cores. When it's doing the operation, it can support. So this hardware-software co-design project requires some of the synchronized innovation because the hardware team and software teams, they must understand each other very well about their desires and their constraints. We have totally different release cycles. We have totally different reporting trees. That means we need to talk to each other using a portable interface. This interface should be lower level than a SQL relational algebra or SQL operation, but must be very higher level than load store instructions. And in this case, we define a set of micro operators. What we hope, we can represent the query using those micro operators. We can cause those micro operators, optimize them, and implement it and specialize on different platforms. So let's look at how we can represent the relational query using the micro-operator. This is a very simple two-table joins, and here is how a traditional SQL plan look like. And after we using the micro-operators, the plan will look like this. Instead of have two scan and one joins, we on the build tables, we need to do recode, doing a hash, doing a partition, and building a hash table on top of it. And on probe side, we need to do a recode, hash, probe, and using the result to do a late materialization and ultimately give the result. So instead of 3, 1, here we have 1, 2, 3, 4, 5, 6, 7, 8 in total operator. But the execution mechanism is not so different. We're still using the execution engines, take the graph of the micro-operators, invoke those micro-operators, completely hide the implementations on different platforms. In Oracle, we have the portable C implementation. We have a DAX implementation to support our SPARC. We have a SIMD implementation to take advantage of AVX. However, this final grade planning, decomposition, and also the expansion of the SQL plan and per platform implementations give a new opportunity for the optimization. Our optimizer is based on the per micro operator cost models. It has 3 properties. One, it must be platform aware because platform have their metrics, the cache size, the core type, the core count, different memory bandwidth, and we have different platforms, different implementations for each of them. The second one should be resource adaptive. We need to choose the plan match the current resource availabilities because the runtime is so different from the compilation times. And also when there's a concurrent workload running in the systems, we must balance. We have to choose our optimization goals, whether we want to minimize the memory bandwidth or we want to minimize the CPU cycles. The third one is self-involving. Because we think we can benchmark the micro-operator and improve the cost models. However, we also can using the collected measurement from the execution times and automatically improve the model. To sum up, we want to use the specialized plan and optimize implemented in the specialized algorithm running on the specialized hardware, and you will have the biggest gain. Thank you.